Hello everyone and welcome to Gradeup. My name is Ashish Sir and today I am here to present the lecture on consolidation. Now this is the third lecture for soil mechanics which we are doing. Okay, so we'll wait for more viewers to join this session. Abhinav Panchal is saying as per SSC only 4 to 5 marks come from soil mechanics. Abhinav, see 4 to 5 marks which you have drawn the weightage of soil mechanics, I think it's slightly on the lower side, okay, because soil mechanics holds a greater importance. So I believe the weightage is much more than what you are saying, okay. For RRB definitely this subject will have good weightage, but since the pattern is changing, the exact weightage cannot be predicted, okay. There is one more thing about this RRB JE. Today there has been a notification, okay, a notice for language change request, okay. So this notice has been released by RRB JE for changing this language. Second language, first will definitely be English, okay. So the secondary language which you have already given, you can change, okay, and the dates are from I think it was from 24th, yes, 24th of April till 1st of May, okay. So during this period you can change if your secondary language is not proper in your forms, so you can change. Just log into your using your login and password, you can user ID and password, you can log in and see if these languages are correct, okay. Also there was the session on first session of soil, that is soil properties. The formula for gamma D 1 minus eta A G gamma W upon 1 plus GW by S, okay. So this is the correct formula. I think I have written here E, okay. So just correct that, okay. Vishal Datta is saying, sir, for those whose application have been rejected due to photoshops, will they be? I see. I'll get back to you, but I don't think they will give any more chances, okay, because the forms have been submitted. That process of doing addition or subtraction in the form is during the application process, and since it is over, I don't think that will be an option given to you, okay. Sorry. Okay, so now we'll start our session. Now, consolidation. So on a broader term, first of all, there is a term known as compressibility, okay. So compressibility, as the name suggests, compress means decrease in volume. So this is gradual decrease in volume of soil, okay. So that is known as the compressibility of soil, okay. Now this compressibility can be in form of compaction or in form of consolidation, okay. So compaction and consolidation are forms of compressibility, okay, by which compressibility is achieved. It can be either through compaction. Now what happens in compaction? It is due to expulsion of pore air, okay. So in compaction the decrease in volume of soil is due to the expulsion of pore air, while in consolidation there are again two divisions, that is primary consolidation and there is secondary consolidation, okay. So this primary consolidation is due to expulsion of pore water, okay, and secondary consolidation is due to the plastic readjustment of soil structure. Okay. So, after primary consolidation has been achieved, there are plastic readjustment, there are readjustment in the soil structure, and that leads to secondary consolidation. Okay. This will occur in a very later stage of the structure. Okay. So, this is the prominent one, okay, and this will be our focus mainly in consolidation chapter. This is the prime focus, this is not the prime focus. Okay. So, compressibility, it is gradual decrease in volume of soil. It is achieved by either compaction or consolidation. Compaction is due to the expulsion of pore air. Consolidation, it is either primary or secondary, okay, and due to expulsion of pore water. Primary is achieved by expulsion of pore water, and secondary is achieved by plastic readjustments. Okay. Now, in this during consolidation, okay, so properties which increase, okay, so properties which are enhanced, okay, so properties which increase are, first of all, the settlement increases, okay, as the consolidation occurs, this primary consolidation occurs, the soil will settle more, okay. Second thing is effective stress, okay. So, here the second property which increases is effective stress, okay. If effective stress increases, that means shear strength increases, okay. Shear strength is C plus sigma n bar tan phi, okay, and sigma n bar is effective stress. So, if effective stress will increase, that means shear strength will increase. Also, due to this, due to the because due to consolidation it has compressed, okay, so dry unit weight also increases, okay. So, these properties are increased due to consolidation. Now, there are certain properties which decrease, okay. So, properties which decrease, first one is pore water pressure, because pore water pressure has been removed, it is being expelled, so pore water pressure decreases, okay. Second thing is permeability will decrease, because now it is in a closer matrix, okay. So, voids have been reduced, that means permeability will be reduced, okay. Then water content will be reduced because water is being removed, okay, and last but not the least, the void ratio will decrease, okay. Now, properties which remain same, okay. So, properties which remain same, I think it is not visible. Okay. So, properties which remain same are or is total stress, okay. So, total stress will remain same. Now, total stress is comprised of effective stress and pore water pressure, and I am here I have mentioned this effective stress will increase while pore water pressure will decrease. So, this will conserve this, okay. So, total stress will remain same. Please take a screenshot of this, okay. So, you may get objective theoretical type objective questions from these topics, that is why I have mentioned it, okay. So, just note them down. All right. Now in consolidation you might have normally consolidated soil, over consolidated soil, okay, over consolidation ratio. Now we will discuss those things, okay. So first of all, normally consolidated soil, okay. So what is normally consolidated soil? Now any structure or any soil will have experienced some stress in the in its past, okay, and currently also there will be some stress, okay. So if in short I write present is greater than equal to past, okay. Now we'll elaborate here and then we'll come to this one, present is greater than equal to past, okay. So here soil which is subjected to stress which is higher than pre-consolidation stress, okay. So currently the soil, the stress which is acting on this soil, okay, it is for the first time that this soil is experiencing that much high stress, okay. In that case this soil will be called as normally consolidated soil. So present stress is greater than equal to past stress, then the soil is said to be this normally consolidated soil, okay. Then what is over consolidated soil, okay. So over consolidated soil will be present is less than past, that means the soil which is subjected to stress less than the pre-consolidation stress, okay. So currently the stress which is acting on this soil, the soil has experienced a higher stress, this value, the stress which is current today, it is less than pre-consolidation stress, then that soil is said to be over consolidated soil, okay. Now third is over consolidation ratio, that is OCR, okay. Now OCR is maximum applied effective, these all stresses which we are talking in consolidation chapter, these are effective stresses, not total stresses, okay. So do take care of that, this language, effective stress in past divided by maximum applied effective stress in present. In short, you can also remember it by past divided by present, okay. Now for over consolidated soil, okay, for over consolidated soil it is the present is less than past, so for over consolidated soil this will be OCR will be, because in the past it has experienced greater stress while current stress is less in over consolidated soil, so OCR will be greater than 1, okay. While for normally consolidated soil the past is less while present stress is more, okay. So it will be less than equal to 1, okay. So this was about these 3 terms, okay. I hope they are clear to you. Now void ratio versus effective stress for NC soil. Okay. So there are two variations which you can find in your notes and books also. Okay. So there is E void ratio and sigma bar effective stress. Then there is log sigma bar and E. Okay. So if this for normally consolidated soil, the graph is curved, okay, while for with log it is straight. Okay. So this is sigma naught bar, and at some point here this is E naught, this is sigma 1 bar, okay, and this is E1. Similarly here this is E naught, this is E1, this is sigma naught bar log, here it's log sigma 1 bar. Okay. So these are the variations. This the only difference is here it is log, here log is not present here. Okay. So from this graph the slope is, we get coefficient of compressibility. It is denoted by AV, and AV is equals to delta E upon delta sigma bar, which here will be, higher one is E naught minus E1 divided by sigma 1 bar minus sigma naught bar. Okay. So this is coefficient of compressibility. If you talk about the units here, units will be inverse of stress, that is meter square by kilonewton. Okay. Meter square by kilonewton will be the units of this. Okay. Then here it is coefficient of compression, also known as compression index. It is represented by Cc, and Cc is delta E upon log sigma 1 bar upon sigma naught bar. Okay. And this, the unit is, it is dimensionless. Okay. So this is dimensionless. This compression index is very important, because for calculating this primary consolidation settlement, the value of Cc will be used. There is a formula and we use value of Cc in that also. Okay. Also there is two important things about note. Okay. So for undisturbed clays, Cc is equals to 0.009 WL minus 10. This is an empirical formula. Okay. I think it's not clear here. I'll write it in next slide. Okay. Just take a screenshot of this. All right. Okay. So for undisturbed clays, Cc is equals to 0.009 WL minus 9, where WL is liquid limit in percentage. Okay. For remolded clays, Cc is equals to 0.007 WL minus 7, and WL is liquid limit only, and in percentage you will represent, put the values. Okay. Then this was for the normally consolidated soil. If we plot void ratio versus effective stress in over consolidated soils. Okay. So, in over consolidated soils there will be stages. Okay. So, this is initial stress, this will be the past stress, okay, the pre-consolidation stress, this will be the pre-consolidation stress. Here it is void ratio. Okay. So, like here it was concave, this is concave, this is straight. Okay. Here it will be convex for this portion, okay, and then it is again concave, okay, because now it has entered the normally consolidated stage. Okay. So, here the variation will be convex, here it will again be concave. Okay. Now, this is for log. So, log of sigma naught bar somewhere here, log of sigma 1 bar past. Okay. So, here it will be slightly concave, okay, it will almost be straight, and here it will be straight. Okay. So, this is the variation. So, with these 4 graphs you can see the difference. This is for normally consolidated soil and this is for over consolidated soils. Okay. These may come in objective questions. In you may be given any graph and you may have to work out for which type of soils or which condition they are saying. Okay. So, just have a look at these. Also here, like for normally consolidated soils, these are the indexes, the coefficients which you have to use. Now, for this over consolidated soil, you have to use coefficient of recompression. Now, it is the formula is quite similar to coefficient of compression index. The only difference is that it is having a lesser value compared to Cc. Okay, because this over consolidated soils are already so much of settlement has already occurred that they will not have much settlement now. Okay. So, if that value is small, that means coefficient will also be small. Okay. So, Cr is equals to delta E upon log to the base 10 sigma 1 bar upon sigma naught bar. Okay. Sigma C. This will be the pre-consolidation stress. Okay. Please take a screenshot of this. Okay. Now, as you may be aware that this consolidation chapter, the most important contribution was of Tarjagi. Invariantly, the most important contribution in entire soil mechanics is of Tarjagi. That is why he is known as the father of soil mechanics. Okay. So, there is the theory of Tarjagi, one dimensional 1D consolidation equation. Okay. So, entire theory from objective point of view, it is not important to discuss that, okay, because it will take too much time and I do not think from examination point of view that is important. Okay. So, the equation which he proposed was del u over del t is equal to Cv del square u over del z square. Okay. Del square u over del z square. Okay. Now, u here is pore water pressure. So, del u by del t is variation of pore water pressure with time, while del u by del square u by del z square is second derivative of the variation of pore water pressure with the depth. okay, and CV here is, now CV is coefficient of consolidation. This is another coefficient. From this consolidation chapter, the coefficients are very important, okay, because they may be confusing, okay, in examinations. This weakness will definitely exploited by the examiners, okay. Now CV is equals to K upon MV gamma W. This is the formula for that, and where MV is coefficient of volume compressibility, coefficient of volume compressibility, and formula for that is AV upon 1 plus E naught, and AV I have already told, that is coefficient of compressibility, okay. So all these formulas are important, okay, these ones. Then the formula for CC, formula for AV, okay, at least these four are very important, okay. And this MV will remember this formula also, because there is a formula for calculating the consolidation using this coefficient also, okay. So MV and CC, MV and this CC, these are very important, okay. Then there is a dimensionless parameter known as time factor TV, okay. Now TV is CVT over D square. So CV I have already told what is it, it is coefficient of consolidation, okay. T is time of consolidation, and D is length of drainage path. Now there is either two-way drainage, okay. So in that case D will be equal to H naught by 2, and in case of one-way drainage D will be equal to H naught. See, two-way drainage will occur how? If suppose this is some layer, so this is a layer of clay, suppose, okay. So you have to calculate the consolidation settlement of this layer, okay. Now this is suppose sand, here also it is sand, and here also it is sand, okay. So when it is compressed, the water will dissipate from this layer also and this layer also. In this case, if suppose this is of thickness H naught, okay. So in this case the drainage path will be H naught by 2, it is two-way drainage, because it is occurring from this layer also and this layer also. While in one-way drainage, if suppose this is one layer, this is clay, and here it is rock, okay. So there is rock here, okay. In this case, if this is sand, so water will dissipate from this, okay. It will dissipate from this, but not from this layer. So in this case, the farthest point from which water will have to move is from here to here. So length of drainage path is H naught, while from here the farthest is from center to this distance, okay. So this the water at center will can travel from this point to this point, or this point to this point. So the longest length of drainage path is H naught by 2 here, and here it is D is equals to H naught, okay. I hope you have noted this down, okay. Now this depiction we have done, drainage path we have studied. Now formulas for TV, U upon 100 whole square, and this is valid for degree of consolidation less than equal to 60%, okay, and TV is equals to 1.781 minus 0.9332 log to the base 10 100 minus U, and this is valid for U greater than 60%, okay. Also units for CV, see from here CV is equals to TV into D square by T, okay. So TV is dimensionless, D units of D will be length square, that is, let us suppose meter square, and time is, let us suppose second. So TV will be equal to length square divided by time. Okay, time may be in second, days, or anything. Okay, so the units will be meter square per second or centimeter square per second in this case. Okay. Now there is one more term, that is, now there are two methods to calculate this value of CV. One is Taylor's square root fitting, Taylor's square root of time fitting method of time fitting. Now this is corresponding to U is equals to 90%. Okay, degree of consolidation 90% you have to achieve. So TV 90 is equals to CV into T upon T 90 upon D square. Okay. So TV 90 for 90%, this is greater than 60, so this formula will be applicable, and if you calculate TV 90 for 90%, the value of TV will be 0.848. Okay. So using this formula you can calculate the value of CV. T90 you will have the data for how much time it took to the 90% consolidation. Okay. D square, length of drainage path, you will be knowing. Then the second one is Casagrande's square root of time fitting. Now difference is U, for U here it is 50%. Okay, you can also remember by this, C comes before T, so it is less than 90. Okay, this is 50, this will be greater. T is at C comes before, T comes later, so it will be greater, that is 90%. Okay, so TV 50 is equals to CV into T 50 by D square, and if you calculate for 50%, this formula will be used because it is less than equal to 60%, and that is 0.196, that is CVT over T 50 over D square. So using this formula you can calculate the value of CV. Okay. In case of 3 layers, how it becomes H by 4. Okay. So suppose originally the soil was like this, here it was clay, here it was sand, these two are permeable layers, this is impermeable, and you have to find the consolidation settlement of this. Now is suppose a very thin layer of sand occurs at middle layer. Okay. So originally this was H0. In original case the length of drainage path was H0 by 2. Okay. Now since here now 3 layers, this is one layer, this is second layer, and this is third layer. This is first layer which is permeable, this is second, and this has come just now. Okay. So these are 3 layers. Now in this case the greatest distance which the soil the water has to travel is this much only. So half of H0 by 2, that is H0 by 4. Okay. So I think Aman, your query will be resolved with this diagram. Now the most important part here is determination of consolidation settlement. The entire chapter comes to this. Okay, all this was the things which we have to use in order to calculate this. Okay, now 3 formulas are very important from examination point of view. I am writing it here, and I think you should remember them by heart. Delta H by H0 is equals to delta E upon 1 plus E naught. Delta H is consolidation settlement, H0 is initial thickness of the soil sample or soil medium. Okay, delta is change in void ratio, and E naught is initial void ratio. Okay. Now, second formula which is important is delta H is equals to mv h naught into del sigma bar. Okay. So, I had told you that mv and cc, these two are used to calculate the consolidation settlement. So, that is why these are important. Okay. So, delta H is consolidation settlement, mv is coefficient of volume compressibility, h naught is initial thickness, and this delta sigma bar is change in effective stress. Okay. Third formula which is important is Cc upon 1 plus E naught H naught into log to the base 10 sigma naught bar plus del sigma bar upon sigma naught bar. Okay. So, this was the initial stress, this is the change in effective stress. Cc is coefficient of compressibility or compression index. Okay. E naught is initial effective stress. E naught is initial void ratio, sorry, initial void ratio. Okay. Now, suppose there is some structure, the initial stress was this much, then it went up to the pre-consolidation stress sigma c, and then the stress which it experiences is this much, and you have to calculate the consolidation settlement. Okay. So, in this case what will happen is delta H will be equal to, now for this part, since this the soil has already experienced consolidation up to this in the previous history. Okay. So, in its past it has experienced this much stress. So, from this stress to this stress, the coefficient which you will use is coefficient of recompression, and here you will use Cc. Okay. Formula will remain same, but there is one more thing which is to be taken care, and I will. Okay. So, here now this will be sigma c bar upon sigma naught bar. Okay. Plus here it is Cc upon 1 plus E naught H naught log to the base 10, here it will be sigma 1 bar upon sigma c bar. Why I have not written this? Because delta sigma, you either take a difference and then add sigma naught bar plus this delta sigma, and here also you can write sigma c plus delta sigma 2. Okay. But that is immaterial, because we are writing what is today's stress getting applied here, and this is the previous stress. Okay. So, here this thing you have to remember. From JEE point of view and objective point of view, this will not be very useful to you, but because such questions will not be asked in objective questions. Okay. This is more conventional point of view, but many students do mistakes here, so that is why I have written this. Okay. Sir, once again, I hope you are asking about this. See, initial stress is this much. Okay. This is pre-consolidation stress, and this is the stress which we have to reach. Okay. This is the final value. Okay. And you have to calculate the consolidation settlement. So, from this to this stress, you have to use coefficient of recompression, and from this stress to this stress, you have to use coefficient of compression index. Okay. So, recompression you will use here, and stresses which you will put is this by divided by this. While for calculating from this value to this value, you will calculate, you will put this stress divided by this stress. Okay. So, just whenever you get a question like this, make this line. Okay. It will diagrammatic representation 1 or 2 times, then you will easily remember this. IS code specification. IS code specification for permissible settlement. Okay. Isolated footing on sand. There are two things to note here. It is an isolated footing and it is on sand. Okay. So, permissible settlement is 40 mm. Okay. Second is footing is isolated only on clay. Okay. So permissible settlement is 65 mm. In objective questions directly these values can be asked. Okay. Now if I talk about raft on sand, it will be 40 to 65 mm. Okay. And if I talk about raft on clay, then it will be 65 to 100 mm. Okay. Please take a screenshot of this. Okay. And now this is the theory part. Now we will move to the questions. Okay. So first question, Khushi Adhikari is asking what is the difference between CR and CC. Please just concentrate on these sessions. It becomes difficult to repeat. Okay. This is coefficient of recompression. Okay. This is for OC soils or consolidated soils. Okay. While CC is for normally consolidated soils and it is coefficient of compression. Okay. So if the soil is already consolidated to a higher value of stress, then we use CR in that stage. Okay. While if this present stress is for the first time the soil is experiencing, in that case we will use coefficient of compression. Okay. Just rewind the video a bit and you will get the exact idea. Okay. If you are having still having the doubt. Now come to the question. Now the degree of consolidation is 50%, and you have to find what is TV here. Now there are two cases I have told you. One is for U less than equal to 60% and another one is for U greater than 60%. Now this falls in the category of first case. So the formula for TV will be pi by 4 into U by 100 square. Put the value of 50 here and get the answer. The value of TV exactly you will be getting 0.196, which can roughly be rounded to 0.2. Okay. So correct option is A. Okay. So this is the correct option. Yes. Rohit, you have solved it correctly. Yes. Rituraj, you have also solved it correctly. Arnab, Ankita Sharma, D, I think you have done some mistake. Just correct that. Just don't do these type of mistakes. Okay. Divide by 100 you are not doing. Okay. In that case this will increase very much. Next, second question, just on your screen see. The unit of coefficient of consolidation is. Now first of all, what is coefficient of consolidation? It is CV. Okay. And CV in formula form is TV upon TV CVT over D square. So CV is TV into D square by T. So it will be length square divided by time, and the only thing which is matching is centimeter square per second. Okay. So B will be the correct answer. Yes. Prem Sagar, you have solved it correctly. Venkateshan, yes, correct. Ritu also solved it correctly. Yes. So moving to the next question. When the primary consolidation process in a soil is complete, okay, so primary consolidation has been achieved entirely, so then the hydrostatic pressure will become 0. Okay, hydrostatic pressure will become 0. The axis pore water pressure will become 0. Both the hydrostatic and axis pore water pressure will become 0. The effective stress will become 0. Okay, so hydrostatic pressure, no, this will not become 0. Okay, x is 4, will come to this, both, no, effective stress, no, it will not become 0, it increases. So the correct option is 2, that is pore water pressure will become 0. Yes, Vishal Datta, you have solved it correctly. Next question. Loading of saturated fine grained soil results the following processes, that is shear failure first, immediate settlement second, third is pore pressure generation, and fourth is volumetric deformation. So what is the correct sequence of processes above? Okay. So if you are loading a saturated soil, the first thing which you will get is the immediate settlement. Okay, as soon as you will put some material on this, on the soil, you will have immediate settlement. Okay, then due to this immediate settlement, it will come into closure matrix. Okay, and pore pressure will be generated. So pore pressure generation is the second phenomena. Okay, then you will have volumetric deformation due to this. Volumetric deformations, and then the final stage will be, as the load will be increased, it will lead to shear failure. Okay. So as soon as you put the put some load on, if this is the soil and you have put some load into this, first of all there will be the initial or immediate settlement. Okay, then due to this, let us suppose this, it will come to this much. Okay, now since this has compressed, the pore water pressure will be generated. Okay, and it will, the soil will deform, so volumetric deformation will occur, and if you keep on increasing the load, ultimately there will be the shear failure. Okay, so what will be the flow? 2, pore water pressure is 3, volumetric is 4 and 1. So 2, 3, 4, 1, just match it. I think it's 2, 3, 4, 1 is B. Yes. So this is the question. Now next question. Consider the following statements. Secondary consolidation of soil follows Terzaghi one-dimensional theory of consolidation. This you have to see if these statements are correct or incorrect. Okay, so this statement is not correct because it is not secondary, it is primary consolidation, which follows 1D theory of Terzaghi, one-dimensional theory of consolidation. Okay, consolidation is a function of total stress. So this is also incorrect. It is not a function of total stress, as I mentioned in my lecture today. It is a function of effective stress. So first and second both are incorrect. Even after complete dissipation of pore water pressure, the soil undergoes a little more consolidation. Yes, definitely, because this settlement is known as secondary consolidation. Okay, this settlement is known as secondary consolidation settlement. Okay, so third is correct. So A is the correct option. Yes, correct. So this is the correct answer. Next question on your screens. Just extract the data. First of all, 2 centimeter thick. Soil sample is 2 centimeter thick. So H naught is 2 centimeter. Okay. How much is the consolidation settlement? It is 0.2 mm. Then you are given with consolidation pressure, and initial void ratio is given to you, that is E naught is 3. You have to calculate the change in void ratio, delta E. So you have to calculate delta E. Okay. So the formula which you will use is delta H upon H naught is equals to delta E upon 1 plus E naught. Okay. Sometimes this formula you may mistakenly write as this, delta H upon H naught is equals to delta E upon E naught. Okay. Just take care, 1 plus E naught, because in exam pressure these mistakes do occur. Okay. So delta H is how much? It is 0.2 divided by H is 2 into 10 mm. Okay, 22 centimeters, so that is 20 mm. Delta E you have to find out, and E naught is 3. So if you solve this, delta E which you will get is 0.04, and that is, I think, option number B. Okay. So this is correct. Next question. Here you are given with the past stress. Okay, fully consolidated in the past is, so pre-consolidation stress is given to you 225 kilonewton per meter square. Okay, and the current effective stress is 75 kilonewton per meter square. So over consolidation ratio is past upon present. So sigma C bar upon sigma 1 bar, that is 225 by 75. Okay. So the option which is correct is C. Okay. So C is the correct answer. Yes. Just take care that it is past by present. Okay. So by that, because even 75 by 225 is the option, it is A. So you may mistakenly write that. Now the last question of the session. Now here you are given with coefficient of, you are given with table and you have to match those. Okay. So the P, coefficient of compressibility. Now coefficient of compressibility, I have already told you, it is E versus log sigma bar. Okay. Coefficient, E versus sigma bar. Okay. So E versus sigma bar, that is 1, correct. Q, it is compression index, so it is E versus log sigma bar, so that is, I think, 2. Yes, correct. Then R is coefficient of subgrade modulus. Subgrade modulus is K, that is P by delta, or also be termed as stress upon, this is deformation. Okay. So it is stress divided by deformation, stress versus deformation. Okay. So it is 4. All right. And S is what? Coefficient of consolidation. Okay. S is coefficient of consolidation, that is time versus void ratio, E. Okay. So it is 3. So the series becomes 1, 2, 4, 3. Okay. And the option which is matching is B. Yes, correct. So here B is the correct option. Right. So with this we have come to the end of this session. I hope this was helpful to you. We have just one more session for soil mechanics planned, and that will be of bearing capacity. Okay. So thank you for watching this video, and please prepare well and have a very good day.